Hello and welcome to the third probability video, and on this one we're going to be looking at expected frequency, and that means we're going to be working out how many times we would expect something to happen if we know the probability. Now so far we've looked at what happens if we do something once. Now what happens if we do it many times? So a fair unbiased dice is rolled 60 times. How many times would you expect it to land on the number 5? Well, first of all we need to know what would happen on one roll. And we say on one roll, the probability of getting a 5 is 1/6. We've done that in the previous two videos. So on 60 rolls, we would expect, and the key word here is expect, we're not saying it's definitely going to happen, but we would expect there to be 60 times 1/6. Now 60 times 1/6 is 10 5s. So what we do, we get the probability of the outcome happening once, and we multiply it by the number of times we're going to repeat it. Okay, let's have a look at another example. We've got a fair unbiased spinner. It's got 4 equal segments, 4 numbers, 1, 2, 5 and 11. It's spun 100 times. How many times would you expect it to land on an odd number? So we're not saying it's definitely going to land this many times, but we would expect it to land this many times. So once again, let's work it out for one spin. Probability of getting an odd number. Well, how many odd numbers are there? 1, 5, 11 is 3 out of 4. So the probability of getting an odd is 3/4, which we could write as 0.75. So for 100 spins, we would expect there to be 100 times 0.75, which is, in other words, 75 odd numbers. Okay, let's have a look at some exam questions based on what we've just learned. A bit bright, isn't it? Well, so we've got a game where a player rolls a coin onto a board, marked out in squares. The squares on the board are red, blue or green. If the coin lands entirely within one of these squares, the player wins a prize. So there's the probabilities of the coin landing entirely within each coloured square. What's the probability that the player wins a prize? Well, the probability that the player wins a prize, we just add up the probability of it being completely within a red, a blue or a green square. So we add those up and that gives us, let's have a look, 0.13, line up the decimal point, and we get 0.31. So the probability of winning is 0.31. Now, part B says, one day 200 people play this game. How many people would you expect to win a prize? So just as we did with the other examples, it's 200 times 0.31. Now this is off a non-calculator paper, so it could be a bit tricky doing that. Let's make it easier. Let's say 2 times 100 times 0.31. Now 100 times 0.31 is 31. 2 times 31 is 62. So we would expect 62 people to win that game. And this is one we've seen before. Karen with the cards. She's got 12 cards, 4 yellow, 4 red, 4 blue. The yellows are numbered 1, 2, 3, 4, as are the reds and the blues. Write down all the possible outcomes. Where we did this on one of the previous videos, and we could have a yellow with a 2, a yellow with a 3, a yellow with a 4, and a red with a 1, 2, 3, 4, and a blue with a 1, 2, 3, 4. There are all the possible outcomes. What's the probability of someone winning? And remember, they win a prize if it's a red with an even number on. So the probability of winning, there are 2 ways of winning out of a total of 12 possible outcomes. Now we can reduce that to a 1/6. We don't have to. We don't get any extra marks for doing it, but it might help us. So what we really want to look at here is part B, part 2. One day 120 people play this game once each. That means how many people would you expect to win a prize? Well, the probability of winning times 120 will give us the number of winners. So it's 120 times 1/6, and that's the same as 120 divided by 6. So we would expect there to be 20 people to win there. Okay, that's that. So have a go at the exercise, and I'll speak to you on the next video. Good luck. Bye for now.